Welcome back. Just wanted to continue working on our lecture series. We're going to be talking today about the motions and phases of the moon. So let's label the lecture lunar cycles. Let's see. Zoom in a little bit. Lunar cycles. Okay, the essential question is what are the motions and phases of the moon? What are the motions and phases of the moon? Okay, so let's start with some basics. First of all, the moon. It's a satellite, a satellite of the Earth. Pretty obvious. Then we'll continue. Let's talk about some common things associated with the moon. First of all, it rises on the east and sets on the west. On the west, pretty standard celestial movement. Approximately distance, at a distance of approximately 400,000 kilometers. Compared to the mass of the Earth, it's about 1/8 of the Earth. Mass is approximately 1/80th of Earth. I think I said 1/8, it's 1/80th. There is no atmosphere. And it's useful for reconstructing our planetary history. Useful to reconstruct planetary history. Okay, so let's talk about the phases of the moon and go right into it. You need to understand that the moon is the movements of both the Earth and the moon in combination with rotation around the sun can become quite complex. So don't feel discouraged if at first it doesn't make sense, but or what you observe is what it. We're going to be learning about this as we do observations. But if you take a look at the Earth, I'm going to put the Earth in the middle in this case. Okay, and what I'm going to do is I'm going to draw the lunar month in about 29.5 days. I'll make a comment on that, but just follow the drawing. We're going to draw 8 circles around the Earth. This is looking at it from the North Pole, so we're looking at it from the top. And so here is 1, quarter of it, 2, 3, 4. Try to be careful when you draw these, just so it'll make sense to you. 6, 7, and 8. Okay, we're going to go ahead and number them. 1, 2, 3, 4, 5, 6, 7, and 8. Now, a comment on this is the lunar month is 29.5 days. So let me put that on the side while you're drawing that. Lunar month is 29.5 days. You can understand where the term month comes from, moon. So let's take a look at, in addition to that, you need to know where the sun is at. So let me go ahead and use a yellow type of pen. But the sun rays are coming in this fashion, like this. Maybe you can't quite see it. I'll make it a little bit. This is the sun rays coming in. And there we go, like so. Now the way the moon would end up looking, if you would just divide it in half and just darken the side that's not being illuminated by the sun, like that. On all of these, like this. Okay. Remember, this is the top North Pole, and then the not illuminated part is right here. Now the question is, what does that result in? So the sun rays are coming in, and so each one of this particular images I'm going to go ahead and draw underneath and see what the moon looks like, to be able to draw the different phases of the moon. So I'm going to draw 8, hopefully spaced out here nicely. So you would have 1, 2, 3, 4, 5, 6, 7, and 8 at the end. Now, number 1, and then let's number them so we know what these are. 1, 2, 3, 4, 5, 6, 7, and 8. So when the sun rays are hitting the moon and the earth is in this position, we do not see it. So that would be, we don't see the moon, that would be a new moon. So 1 would be a new moon. When it's in position 2, we would have a waxing crescent. And so the moon would be like this. You only see a sliver of the moon, and this would be dark. And of course in the new moon, it's all dark. Like this. You don't see it. So you have a new moon, and this one will be called a waxing crescent. Crescent. Okay, and then the next one would be right in half, like this. You can't see that. Number 3 in this case. This one would be first quarter. And if there's no room, I'm going to just put an arrow there. First quarter. In this case, you would have number 4 would be a waxing gibbons. So we see more of the moon. This one will be a waxing gibbons. Waxing gibbons. Number 5 will be a perfectly full moon. Right? It makes sense. The sun rays are coming in. Number 5, you will only see the full moon. Okay, so this one will be full. Number 6 would be a waning gibbous. And this one would start showing up on the right hand side here, if you will. This would be a waning gibbous. Gibbous. Seven would be third quarter, so that would be basically, you take the moon and like that. In this case, this would be third quarter. Third quarter. And the last one, at the very end, there's a sliver. Like that. And this one would be a waning crescent. Waning crescent. Okay, so that should be able to explain to you the phases of the moon. Once again, as you go through the different phases across the entire month, you will see that you end up seeing the moon in these type of phases. So that should be easy enough to identify. No, but the motions are more complex in a way, so we got to do a couple more things. I'm hoping that if you need to pause it or whatever, you're more than welcome to, and then continue as you need to. Okay, so I'm going to flip over to the back and do the motions as you would end up seeing it across the given different days. So in the back, once again, if you take a look at, let's do something slightly different, so maybe hopefully can clarify some things. But if you take the Earth, and let's put ourselves in stick figures here like this at 5 different places, if you will. We're sitting at different times. Let's see, right here, I guess. Good enough. Okay, so I have a cells in a different type position. So let's say this is the afternoon. This is the sunset at sunset. This is at midnight. This is at dawn. And this is in the morning. Now, if we have, in this case, I'm going to go ahead and draw the sun. Still the sun is in the afternoon, so the sun is here. So we still see the sun. Now, I'm going to do the moon. In this case, this is day 4. This one is day 8. And it would be, the moon would be at first quarter. Something like that. Day 11. And then midnight, day 15. This is a full moon. Day 15, full. And then day 19. And then third quarter will be a dawn, day 22. So this is day 19 and day 22. Now, this is third quarter. I just abbreviated the DQ. Okay, so this is what you would end up seeing. So let's assume across the entire, all across the month, the different days, and at different views of the moon. That's what I wanted to kind of show you, so you can get an understanding of how the moon seems to appear at different times, including during the day. So the idea behind this is, for example, on day 4, if you were to look at day 4, this will be this afternoon, in the afternoon, you will both see the sun and the moon at the same time. So if you take if this is like a set of hills or mountains, you would end up seeing basically part of the moon shown, and then you would also see the sun still shining. You've seen the moon during the daytime. You wonder why. Well, this is the reason why. Okay, and day 8, let me do day 8 next to it. Day 8. Now, it's a sunset, so you're seeing both the moon and the sun at the same time, but at sunset. So if you have the same type of hills here, you might end up with sunset, like right there, where the sun is setting, and the moon more overhead, like this. Okay, that would be day 8 up here. Now the same thing, day 11. Day 11, so we have our set of hills here. You would end up having the moon on day 11, showing you a different phase of the moon. Now, no sun, obviously. Day 15. Now, day 15, you would end up having the hills, but the moon would be lower. Now, day 15 is a full moon, so it would be beautifully set right there. Day 19. Day 19, it would be your hills, and then the moon appears on this side like this. And day 22, you might have the hills, and then the moon appear more like this. Okay, so that will be third quarter. You get the idea that you can see the moon during the daytime. It's out there, and obviously as it goes through its different phases, depending on the time of day and where in the month it is, you'll be able to see the moon. Hopefully that will help explain some of the things, how come I can see the moon during the daytime. So hopefully that will be helpful to you. And the last thing I need to do is just go over, and it's a little bit of a myth buster, and I can illustrate it down at the bottom here, and then we'll keep it to one page. And that is that the moon does not rotate. Well, the moon definitely rotates, and the moon rotates. I'll say down here, I'll put it as a summary, if you will. The moon does rotate. Okay, and the best way to illustrate that is, if you will, I'm going to draw the Earth, and I'm going to draw, but you can see how this works is if I take 1, 2, 3, 4, 5, 6, or maybe 7, I don't know, something like that, different places of the moon. If I was to divide up pointing an axis pointing to the Earth, oh, this is a very small moon, so I'm going to do it a little bit bigger. Okay, like that, you will notice that it will actually, if I take this little quarter right here, and now I'm over here, this little quarter will end up, as it goes around, and I'll color it in a different color in 1 second, so you'll see that the moon definitely rotates. Now, how long does it take to rotate? That's another story. It's 28 days as well, so just approximately 28 days. Okay, you see this portion of the moon? As it goes around, it's actually rotating. Okay, hopefully you get the idea that the moon itself is rotating as it goes around. And so it takes a complete approximately 28 days to rotate around the Earth, orbit the Earth, but at the same time it takes for it to rotate upon itself 28 days. Now, it's synced up in such a way that only one side of the moon appears to look at the Earth at all times. So thanks a lot. Hopefully it was a little bit useful to you. And you're done. Thank you.